Hello, my name is Jay. I just want to show you guys what I did with with this ventilator I'm designing. I just want to give people some ideas out there because I've seen some strange things out on the internet. So this is what I've got. It's a dashboard for the ventilator. I'm using Node-RED as the engine. It's kind of an experiment. I never used it before, but I like some things and I don't like some things, but that's besides the point. So we have like an on-off kind of thing. Breathing rate, I think we're set for like 40 breaths per minute. Tidal volume, 1,000 I think is more than we want to stick in a person of air. And flow rate. So I decided to use a Raspberry Pi. There's many controllers you could use. I like Raspberries, but you could use Arduinos. A lot of people are doing it with Arduinos. This is like a stepper motor hat. So Arduinos. Yeah, so these are stepper motors. This one happens to be 1.8 degree, 200 steps over 360 degrees. And I have like a homing switch. This stuff will make sense in a minute. So we'll just go ahead and turn it on. Oh, and the cool thing about this is it's kind of like this Node-RED I'm using. You program it up with JavaScript and a little bit of Python, and it's IoT kind of thing. So there's a lot of IoT type things you could do, like turn it on with Alexa. Alexa, turn on the ventilator to 10%.
Starting.
So I don't know if you saw that, but basically it located that limit switch because it needs to know where like the home position, they call it. Anyway, so this is sweeping back and forth about 90 degrees. So 90 degrees is my maximum. So basically, in theory, what this contraption is going to do, it's taking rotational movement and making it linear. Anyway, so the back and forth on this left-hand side would be like a bag, like a bellow bag. So that's on order on there. So it's moving maybe about 4 inches. And the nice thing about bellows bag is it's kind of linear. It's a rectangular type, like a cylindrical rectangular thing. So if I move like an inch, I know how much volume, in theory, that's supposed to go into somebody's lungs. So anyway, so if you notice, this is swiping about 90 degrees. So if I want to put less air into somebody, we just go in here and say I cut it down to like half. The cool thing is this thing has air checking, so if I go up, it says 1,000 is my maximum. So say I put a bunch of 9s in here or something like that. So you get warnings. So anyway, I'm going to go ahead and stick 500 in here. Oops. 500. Okay, it took it. So there it goes. So at this point, we're moving 45 degrees back and forth versus 90. So that's what that tidal volume is. So I'll stick that back. Stick it back to 1,000. I want to show you something else. So now it's going to sweat back and forth 90 degrees. Got some cool graphs over here. So at this point, the breathing rate, although it's set for 40, the set point is 40, I'm only getting 37.6 out of there. And the reason for that is we're not moving fast enough. We're a little bit on the slow side. We can't do 38. So basically, to move faster is this flow rate. It's how quickly you push oxygen into somebody. So we have 1,000, and I crank it up. And basically, this is, in this case, this is just for me. This is debug. This is 1,000 hertz. This is how fast I'm moving these stepper motors. So I'll crank this all the way up, which is about 8,000. So you see that it's cruising now, and now it has to pause before it goes back. And at that point, we'll get our 39.9. We should get our 40 breaths per minute, or something real close to it. So that's more or less where I'm at with this project. The next thing I'm going to do is get a pressure sensor for assisted breath. So instead of force feeding the breath, the thing will monitor when a breath wants to be taken, and also sorts of other fun stuff like not overinflating the lungs. Alrighty, let me know if you guys have any suggestions.